I am Stefan Charmot with Ingevity Performance Chemicals. I'm responsible for technical services in Asia. I am located in Shanghai, China, and the topic today is emulsion cold central plant recycling, and I'm delighted to share our China experience with you. We will start with some background information regarding the roadway network in China, loading situation. We'll get into some specification guidelines. Would like to share a few specific project examples so you can really see where we started and what our capabilities are as of today. And eventually we'll wrap it up with some concluding words. Here is a map of the China roadway network. You can see that it's more dense on the east side of the country where most of the population is, where most of the economic activities are. As far as absolute number, our China Expressway network is 170,000 kilometers, which makes it the largest in the world. You can also see how large our lower level roadway network is. So we are really moving from a phase of new construction now to maintenance and rehabilitation. So this is very relevant to come up with a cost-effective way to rehabilitate the roadway network, and is a really good fit for emulsion cold recycling. I'd like to really give you also a feel for how heavy the traffic is on the China roadways, especially the expressway. So you can see here, taking an example of the kind of traffic you can see on the Tianjin expressway, and really fully loaded trucks that are going around. So specifically, you know, how heavy the loads are, we can really, you know, follow what the legal limits should be on average of 10 tons, and usually average weight of a truck should be less than 50 tons, but the reality is a little different. So if we analyze further and specifically look at the axle load distribution by truck type, you can see that most of the axle loads have at least 50% of the axles over the legal limit. And it's to the point that once in a while we have a catastrophic failure, as you can see on the picture on the left, where a very overloaded truck resulted in a bridge collapse. So definitely a very serious loading that we have going on our roadway network here in China. So as a result of that, the typical payment structure that was determined to be most cost-effective for the loading situation is to really use a semi-rigid payment structure. Semi-rigid meaning that the load is carried by a cement-treated base, and then usually on the expressway we have 3 HMA layers on top of the CTB. We call them top, middle, and bottom HMA layers. And roughly we have about 14 to 18 centimeters of hot mix over CTB layers. The use of CTB as part of the payment structure can bring some challenges, especially if too much cement is used in the CTB. Usually the cement can result in shrinkage cracks early in the payment life and create these transverse cracks, really from again cracks initiating from the CTB and reflecting through the entire payment structure. So we would call that bottom-up reflective cracking from the CTB. So these cracks have to really be sealed, otherwise if moisture gets into the base because of the heavy loading, you will get catastrophic failure very quickly. Regardless of shrinkage crack or not, because of the heavy loading that we talked about, eventually in the time frame of 12 plus years, 15 years, you eventually get a structural failure because of the heavy loading and damage of the CTB requiring a major rehabilitation. And the way you have to fix your payment is really removing the HMA layer and fixing the CTB. So that really gives a very big opportunity for emulsion CCPR, because you have to fix the CTB and you have all this wrap that is now made available to be used as part of the rehabilitation technique. Another component that really drives the use of emulsion CCPR is related to policies. So I named a few government bodies with some important policies in the area of recycling, reusing, preventing waste of material, and also some more emphasis on greenhouse gases reduction. So in short, some of the policies are that whatever you take from a roadway needs to be reused at least at around 95%. So again, that's a perfect fit for emulsion CCPR, where you can reuse 90 to 100% of your wrap. Additionally, we see more policies in the greenhouse gases with specific requirements that would really favor a cold mix technique using emulsion, where you have pretty much no emission or greenhouse gases or very limited ones. So next, in order to really implement emulsion cold recycling, we need specification and guidelines. So we are fortunate enough over the years to have had some good revisions of the specification, and now have tools that can be used to really bid project and get successful project. So there are national guidelines, and there are also provincial guidelines that are available to do cold recycling. So getting a little more specific into the details, one of the first requirements is about wrap quality. That's usually a non-issue. Most wrap is really qualified for emulsion cold recycling, and some of the tests are really more for information to make sure some valuable data is gathered. For example, how much asphalt you have in your wrap and so on. But really, the only main really hard requirement is to make sure you don't have any clay contamination of your wrap with the sand equivalent minimum requirement. So usually a non-issue. We like to extract and recover the binder to know what we're dealing with, if it's very aged or not. That can really help the designer doing the mix design to make some good choices when it comes to the job mix formula. Gradation wise, here are some guidelines. So again, not an issue to meet these guidelines. Very often for us, we end up using the coarse or the medium gradation on most of our projects. Emulsion requirements for emulsion CCPR, it's usually a slow set type of emulsion, and we use an engineered emulsion, meaning that it's really designed specifically for cold recycling, with a formulation and a chemical package that is suitable to ensure good coating, good workability, and then also good compactability. And once the mat is compacted, that you get early strength development. So typical requirements, more than 60% residue on your emulsion, and also there's a requirement on coating. Usually it's not a problem. We get pretty much 100% coating, and then some other quality requirement on emulsion, very typical regarding settlement. The next important requirement related to the specification and the mix design for emulsion CCPR is shown here on the slide. So we like to look at air voids to make sure we don't have excessive air voids. So based on the Marshall compaction process, we usually try to get air voids less than 13%. The other requirement that we have is based on the indirect tensile strength. So you can see a picture of the split samples on the left side, and typically we achieve 0.6 megapascal at 15C. There is also a moisture sensitivity damage requirement by running a TSR to make sure we don't have any moisture sensitivity. And then also a very important requirement that we have is around rotting resistance of our cold mix, and we have a wheel tracking test that is part of the mix design done at 60C. You can see the wheel on the left side here of the slide, and then we typically make a slab, we cure it, and then we run the rut test, and we're looking at there is a running rate requirement in the test measured between 45 and 60 minutes, and we need to get more than 2,000 passes per millimeter of rutting. So based on our typical engineered emulsion formulation, the use of some active filler and finding the right emulsion content, we usually can achieve very good rutting resistance, basically pretty much doing a balanced mix design where we get a good cracking resistance, but also very good rutting resistance. Actually, our numbers there from a riding standpoint are equal or better when compared to hot mix asphalt. Next, now is to really move into the field, the construction, starting with the wrap millings from the project. So we fractionate our wrap, and usually we get 3 sizes, 0 to 5, 5 to 10, and 10 to 25 or so millimeters. We can use some virgin aggregate if needed, but most of the time our projects are 90 to 100% wrap. But definitely very beneficial to do some good wrap management. It brings a lot of good control and mixture consistency. Next is to produce the CCPR mix. One of the units that you can use, a highly mobile plant, is the KMA 2200. So usually you have a 2 cold feed that you can use. You have your emulsion tanker that's connected. You have the active filler. It all gets combined into the pug mill and gets loaded onto trucks via a conveyor belt. So here is what the mix looks like at the exit of the pug mill going to the truck. Here is another example of a portable plant that is used on our CCPR project in China. It can be set up in about 7 days. So what's really nice about this plant is that it has 4 cold beams. So that really gives you very good consistency of your mix. But the same idea, you got everything combined into the pug mill, the wrap, virgin aggregate if you use that, water, cement, emulsion, and then gets nicely mixed out of the pug mill and loaded onto trucks. So again, kind of another view of what the mix looks like coming out of the pug mill, and I just want to show you what it looks like. So you can see very well coated mix, kind of with all the trucks lined up to be loaded and going to the truck. So next, once your trucks arrive at the job site, follows the paving and compaction. So we like echelon paving in China, so you can see really right there 2 pavers working side by side, so you kind of prevent anything related to longitudinal joints, even with cold mix. We like to do that when we can. But very key is really the compaction, so that's very critical for success. So we really like to have plenty of rollers and heavy rollers. So usually, you know, some of the requirements for our rollers is to use 2 single steel rollers, 18-20 tons each, with vibratory capabilities, 2 pneumatic 26 to 30 ton rollers, and then 2 double steel 14-ton rollers. So very important to maximize the compaction of the cold mix in the field. So here's really what a paving operation looks like. I'll just run a video so you can get a feel for it, for echelon paving and all the rollers working right behind the pavers. So really a pretty smooth operation, just kind of paying attention to roller passes and make sure that the mat gets well compacted. So another very big important step is quality control overall. So very often we have a QC lab nearby the project, so we do lab testing, field mixed lab compacted samples, checking ITS, checking air voids, doing TSR, and so on. So we really do our control charts, make sure that everything meets spec and the process is under control. And then also for the actual mat testing, one test that's important that we run is the field compaction using the sand cone method, and we target usually 99% of the lab design value. I'd like to share a few case studies to really give you a good perspective of where we started and kind of our progress over the years. So starting in 2006, and then we'll go with some more recent projects so you can see where and how Emulsion CCPR has been used. I'd like to mention that we've done jobs all over China in all the geographies, so we're not worried about the environmental conditions. So from the northern part with freeze-thaw cycles, or from the southern part of China with very elevated temperature and high humidity. So it can work in all kind of climates. So starting with the first case study, that was really our proof of concept in 2006. So this is in the province of Jiangxi, and you can see the existing roadway condition, a lot of cracking, rutting, and actually the picture that you have here also shows the road, the before condition, where it's actually a lot of patching that was done by the DOT to keep the roadway together. So that was again a proof of concept, a pretty large project to start with, about 108 kilometers, to really see what the capabilities of Emulsion CCPR were. So as mentioned, because that was really our first large-scale project, so the idea was to use Emulsion CCPR as really an alternative to the CTB. So see how it would perform as what you could call a flexible base, and then still keeping the typical 3 HMA layers on top of it. So in a way it was kind of increasing the pavement structure a little bit, but taking maybe not too much risk and just leaving the Emulsion CCPR lower into the pavement structure and still putting our 3 HMA layers on top of it. So here is kind of during construction, again, went pretty smoothly in 2006. And then what was really nice to see is that 8 years later, when looking at the performance of the road, there was very minimal cracking, and the reflective cracking really didn't happen, and overall the performance was really excellent. So that gave a lot of confidence to people and the use of emulsion cold recycling. So the pavement really lasted 13 plus years, which is quite amazing, with again the very heavy loading without having to do a major rehabilitation. So we can say that was really a big success back then, and that really opened the door for much more Emulsion CCPR to follow. So the next case study is a few years later, and I just picked a national road example to share with you. Again, typical distress we see, cracking, rutting. So in this case, being a national road, and also I think what was interesting is to take this old distress HMA layer, and then replacing part of the hot mix with CCPR, relatively thin 7 centimeter CCPR, and then just putting a 5 centimeter overlay on top of it. So really the key concept there is, for one thing, one-to-one equivalency thickness between HMA and CCPR, but also to kind of use CCPR as what we would call the middle HMA layer replacement, and see how that would perform and work. So here's kind of like the construction that you can see. So again, the process goes very smoothly, and then the finish mat. In this case, what's very interesting, the roadway was supposed to receive the HMA overlay within a week after constructing the CCPR, but because of logistic issues, there was a delay, and the roadway was open to regular traffic for close to a month, and performed very well under traffic, and eventually the overlay was put on, and the roadway performed very well. The third case study that I would like to share with you is what we've been doing recently. So again, continuing on the capability of replacing the HMA one-to-one thickness and to use it as middle layer with only a relatively thin HMA overlay of 4 centimeters on the expressway. And I think what's really unique now that some jobs require is to do the same day overlay if you really have some lane closure limitations and you want to be able to do the CCPR, do the HMA overlay, and open the road at the end of the shift on the same day. So this is what we've been doing on a few jobs. Again, you don't have to do it this way. It's okay. It's actually favorable to let the CCPR cure for a few days before you do the HMA overlay. But if you have to, in this case, as it's documented, the mix was produced in the morning, taken to the job site that was quite far. Paving of the CCPR was finished around 1:30 in the afternoon. It was left alone to cure for a couple hours, and then we placed the SMA overlay right on top of it, and everything was open to traffic at 5 p.m. on the same day. So turned out to be very successful and can be done. To conclude, I would like to emphasize that since we started in 2006 with Emulsion CCPR, we've completed more than 5,000 lane kilometers and used it in very diverse geographic areas and climatic conditions. Overall, Emulsion CCPR has been a very reliable rehabilitation technique that continues to really gain acceptance for some of the value that it brings, be able to reuse, recycle, and also the environmental benefit with some policies that require that more and more. I believe our success has been really also driven by specification. We have a good specification that people can use as guidelines to build these jobs, and we have more experienced contractor as this technique is becoming more and more popular. So again, our history, we started in 2006. We with a proof of concept using Emulsion CCPR as a flexible base alternative to CTB. And then eventually over the years, we kind of moved up into the pavement structure. And then the next step was to replace the bottom HMA layer for Emulsion CCPR. And then the next step was to replace the HMA middle layer. And of course, you can still do combination of all that, use it CTB replacement, bottom, middle layer, and so on. And as of late, we've been able to do a same-day HMA overlay and open the roadway to traffic at the end of the shift, and doing that on a highly trafficked expressway. Thank you very much for your time. Our China technical team would like to extend their greetings to you. I know the travel situation is limiting, but if it gets better, we invite you to come see us and visit some of our projects. In the meantime, if you have any specific questions regarding this information, please reach out to me, and I'd love to hear from you and some of the projects that you're working on. And also, I would be very happy to put you in touch with some of our other Ingevity representatives in the markets that you operate in. Thank you.